Hello, my dear children. In our last class, we learned about different states of matter. And today, we are going to learn how matter can change its state. Let us see. We can take the example of water for learning this part. Water exists in three different forms. In solid state, it is available as ice. In liquid state as water, and in gaseous state in the form of water vapor. So we know ice, water and water vapor are different forms of water. What happens inside the matter during this change of state? What happens to the particle? And which are the factors affecting this? This is what we are going to learn in this part. Effect of change of temperature. Here we can see the role of temperature or heat energy changing the state of matter, that is from solid to liquid or liquid to gas. Here we can take an activity. Imagine in a beaker we take some ice cubes and we heat it, and we fix our thermometer to check the temperature level. Here, exactly increasing the temperature of solids, the kinetic energy of the particle increases. Due to the increase in kinetic energy, the particles start vibrating with greater speed. So when we apply temperature or when we heat it, the particles of ice cubes absorb the heat energy and it makes changes. The particles start vibrating with a greater speed. The energy supplied by heat overcomes the force of attraction between the particles, and the particles leave their fixed position and start moving more freely. And a particular stage is reached when the solid melts and is converted to a liquid. So that indicates it needs a particular temperature level. When it reaches to that exact point, it converts from solid to liquid state. You understand? Here, from one state to another, when we apply temperature, this particular solid converts to liquid. There the particles, already we learned the position of particles and the movement of particles in different states of matter. So here these factors are affecting the particles and it makes the changes. We learned that when the particle reaches to a particular temperature level, it converts from solid state to liquid state. And we use a general term for that, that is melting point. That is the minimum temperature at which a solid melts to become a liquid at its atmospheric pressure is known as melting point. So here the solid particle reaches to a certain temperature level and then it converted to the liquid state. The process of melting, that is change of solid state into liquid state, is also known as fusion. In the beginning of this session, we had some questions like what happens inside the matter during this change of state and what happens to the particles. Here, the temperature of the system does not change until it reaches to the melting point, that is till the ice melts completely. This heat gets used up in changing the state by overcoming the force of attraction between the particles. As this heat energy is absorbed by ice without showing any rise in temperature, it is considered that it gets hidden into the contents of the beaker and is known as latent heat. Here, the word latent means hidden. So, here the particles absorb the heat energy and gradually it changes from solid state to liquid state. Latent heat to fusion. This is just a definition to indicate the conversion of solid to liquid state. And the definition is this: the amount of heat energy that is required to change 1 kilogram of a solid into liquid at atmospheric pressure at its melting point. Next is conversion of water to water vapor. That is conversion from liquid state to gaseous state. When we supply heat energy to water particles, it moves faster. When it reaches to a particular temperature, a point is reached where the particles have enough energy to break the force of attraction between each other. And at this temperature, this liquid starts changing into gas. In this also, the particle converts to the next state when it reaches to a particular temperature level, and normally we call it as boiling point. When water reaches to its boiling point, it converts to the next state, that is gaseous state. Definition for boiling point. The temperature at which a liquid starts boiling at its atmospheric pressure is known as boiling point. Latent heat of vaporization. It is the heat energy required to change 1 kilogram of a liquid into gas at its atmospheric pressure at the boiling point. Here, it is the conversion of a liquid to gaseous state. Example, water to water vapor. Already we learned the conversion of ice to water, that is solid to liquid state. So you can see it's a step-by-step process. When we apply temperature, when we change temperature, it automatically converts from one state to another state. So we can conclude that state of matter can be changed to another state by changing the temperature. That means when we heat a solid, it converts to liquid, and when we heat a liquid, it comes to gaseous state. Again, you think when we cool, it converts back to the previous state. For example, when you use a plate on top of a boiling water, condensed water in the plate, it's vapor condensed, and again it changes as liquid water. Again, when we freeze, liquid changes to solid, that is ice cubes, right? So this is a step-by-step process. This chart is a comparison of latent heat of fusion and latent heat of vaporization. Here, as we said, when temperature increases, solid changes to liquid state and liquid changes to gaseous state. It's a step-by-step process. But in case of some other substances, solid directly changes to gaseous state without changing into liquid state. We are going to learn about such substances and the process. There are some changes that occur directly from solid state to gaseous state and gaseous state to solid state without changing into liquid state. This process is known as sublimation. Example, camphor and naphthalene balls. Camphor changes to gas while heating. Naphthalene balls we normally use to repel moths and cockroaches. It slowly changes to gaseous state. So these are the examples for the process sublimation. Here the only change is substances directly changes from solid to gaseous state without changing into liquid state. Same case, if the substance is a gaseous substance, there also it directly converts to solid state. Effect of change of pressure. Here we are going to learn how the application of pressure make changes in the states of matter. We learned that the difference in various states of matter is due to the difference in the distance between the particles. What will happen when we start putting pressure and compress a gas enclosed in a cylinder? The answer is clear in this picture. When we apply pressure or compress any gaseous substance, the particles come close together and it is compressed completely into the cylinder. Then gradually it changes the state. So it indicates that applying pressure and reducing temperature can liquefy gases. Example, solid carbon dioxide, which is also known as dry ice. Normally it is stored under high pressure. It directly converted to gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. Here, 1 atmosphere indicate it's a unit of measuring pressure exerted by a gas. So we can say that pressure and temperature determine the states of a substance. This flowchart indicates the different states of matter and the process involved in changing the states of matter. I hope you understand. Thank you.